So in this video, we're going to be talking about the different AI nodes you have access to on n8n. Not the AI agent nodes, the actual AI nodes. And the reason why AI nodes are super relevant today is because 90 to 95% of the workflows that are still being built for businesses are what we call AI workflows. And I've talked about this before, but an AI workflow is basically just a traditional rule-based automation, which is basically just, let's say, for example, a bunch of different APIs you've connected and you're getting the data to transform in some way. And then in the middle of that, you have a large language model, and that large language model is getting the data and then creating some sort of output. And then that's going through the rest of the automation until eventually it gives the output that you desire. And so the idea is that an AI workflow is just a traditional automation that we've had since forever with a large language model added inside it. So now you can automate more processes like blog writing and SEO and that sort of stuff. And so that's why learning how to use large language models inside your n8n workflow is super relevant. And that's exactly what we're going to be talking about today. So to find the AI nodes, you just want to click on plus, and then you want to go to the category called AI. So the first option, AI templates, is basically just going to give you access to all of the templates that n8n gives you for free, so you can import them and use them as you wish. But it's not super relevant for what we're talking about today. The AI agent node is a really important node, which is actually used to build out AI agents. And there's a whole nother module just related to AI agents, so we're also not going to be talking about that right now. What we're going to be talking about, which is probably the most important nodes currently with current capabilities to build out automations for businesses, are these ones here. So OpenAI, basic LLM chain, information extractor, Q&A, sentiment analysis, summarization chain, and text classifier. Now, out of these, the OpenAI node itself is going to be enough for 90 to 95% of use cases. The OpenAI node is basically the node that just allows you to send an API call directly to OpenAI. Whereas these other ones down here do almost the same thing as the OpenAI node, but they give you slightly additional features and functionalities so that you can better achieve certain tasks. And I'll go through each of them in just a moment. But let's start from the most important one, which is the OpenAI node. So if you click into it, you can see that there's 15 different actions you can currently perform on the OpenAI node. These actions sit within 5 different categories. The first category is assistant actions. The second one is text actions. The third one is image actions. Fourth one, audio actions. And the fifth one is file actions. So let's start with the most important action of all, and that's message a model. So message a model, as it suggests, is just basically you sending an API call directly to OpenAI. So let's say, for example, how you can open up ChatGPT on your computer and you can talk to ChatGPT. This is the same sort of deal, but now you're actually sending those prompts or those messages via API to ChatGPT instead of you having to go to their platform and write the prompt directly in the chat box. And so this node is extremely important because it gives your n8n automation access to a large language model. So if you guys want to connect yourself to OpenAI, it's very easy. You want to click on create new credential, and then you want to open up OpenAI API, and it's going to come up with OpenAI platform. You just want to make yourself an account there, get the API key, come back, paste it in here, save it, and you'd now have OpenAI connected directly to n8n. So it's super, super simple. Now, when it comes to sending an API call over to OpenAI, there's a couple of different parameters or options that you have and you can control. So the first thing that you can choose is exactly what model you want to communicate with. Now, as you guys know, OpenAI has a bunch of different models and each of them are specialized to perform a specific task. The main ones that I want you to worry about is GPT 4.1 and GPT-o3 mini or o4 mini. And the reason why I'm saying those two or those three are the most important ones is that generally large language models right now are divided to 2 types of large language models. Number one is reasoning model, and the other one is just normal conversational large language models. So for example, GPT 4.0 and 4.1 are both normal conversational chatbot models. When you talk to these chatbots on ChatGPT, you see that they're very quick to respond, and they're generally good for 80 to 85% of normal tasks. The difference between them and reasoning models is that reasoning models actually think before they respond. And I can actually quickly just show you that. If I go on o4 mini, which is a reasoning model, and I say, what's the meaning of life? As you can see, what happens is it first says it's thinking, and it thought for just a very short second. But generally, it could think for much, much longer than that. Now, if I get the same question and I go to GPT-4o and I say, what's the meaning of life? You can see that it doesn't think, it just starts straight away. And so reasoning models, the ones that actually think, are used to solve complex problems. Just think to yourself, the specific task you want that large language model to complete, is it something that will require the model to solve a slightly complex problem? And I like to think as complex problems as multi-step problems. Something that it's not just quick question, quick answer. It's more so you ask the question, you have to break down that question and then think about it and eventually get to an answer. This would be something like a mathematics question or a physics question, where it's not just something that exists somewhere on the internet and you can grab it and give you a quick answer. Whereas the normal conversational models, they're good for more so just answering the simpler one-step questions. If you wanted to ask, for example, what's the capital of France? Well, that's a one-step question. The answer exists somewhere on the internet and you don't necessarily need to think about it. You will just know what the answer to that is. And so you'd use GPT-4o for the more simple tasks where you don't need to think. But if there is some sort of task where you think it's somewhat more complex, somewhat more multi-step, you want to use these reasoning models. Just do keep in mind that when the reasoning models think, they actually cost you money during their thought process as well. So the more they think, the more it'll cost you. And also the more expensive they are, the more it'll cost you. And so generally, I still use GPT-4o for most of the tasks that I complete. But if I really have to do something that I think requires strong reasoning, then I use something like O4 Mini, which is slightly cheaper than the more higher end models like O3 and O3 Pro. And so once we choose exactly what model we want to go with, let's just say we want to go with GPT-4o, we then can define the prompt, which is what we want to send over to that large language model. So if I come back to my ChatGPT platform, you can see that the prompt will be written in this chat box down here. For example, I can say, "Hi, how are you?" And that's the prompt that I'm sending over. And as you can see, ChatGPT responds with, "Hey, I'm doing great. Thanks for asking. How about you? What's on your mind?" Now I can grab that same exact prompt, put it in here, paste it in, and send it over to ChatGPT again. Now, as you can see, ChatGPT is going to respond saying, "Hello, I'm just a program, so I don't have feelings, but I'm here and ready to help you. How can I assist you today?" So as you can see, we didn't actually have to go to the ChatGPT platform to communicate with it. We literally put it inside the OpenAI node inside n8n, and we were able to send that directly to OpenAI and then get a response back from them via the API. And so that is the idea of a prompt. Now, when it comes to a prompt, there's also three things that you have to know about. The first one is what we call a user prompt. The second one is what we call a system prompt. And the third one is what we call an assistant prompt. Now, these three prompts will generally be combined together and sent over to OpenAI, but they're used for three different use cases when you're sending that specific prompt over to the large language model. So a user prompt is the actual task in hand. It's going to be variable every single time. For example, right now I might ask, "Hi, how are you?" But then tomorrow I can ask, "What's the weather like today?" So it's a specific task at hand, and it's going to be different every single time I want to communicate with that large language model. The second type of prompt that's extremely important is the system prompt. Now, the system prompt is going to be fixed every single time I'm using that large language model. So the idea of a system prompt is that no matter what task I give the LLM, the system prompt is going to be sent as the same exact thing. So generally inside the system prompt, you define the behavior of the LLM. You might tell the LLM that you have to respond in a sad tone. And then that is defining the behavior of the LLM. And so no matter if I ask, "Hi, how are you?" or if I ask, "What's the weather today?" or if I ask, "What's 550 times 296?" it wouldn't matter because this specific behavioral prompt would be the same regardless. And so any part of the prompt that you think is going to define the behavior of the AI and should be the same every single time the automation runs would go inside the system prompt, and anything that's task-based, meaning it's dependent on that specific time the automation is being run, goes inside the user message or the user prompt. Now, when it comes to building complex automation, this is actually pretty important. The system prompt generally ends up being this long, and the user prompt ends up just being this long. Because the system prompt is where you're actually telling the AI what the context is, what the AI's role is, what are some examples of how the AI should respond, and every other thing that you think the AI needs to know how to solve that specific task. But then the task itself, which is usually a little bit shorter and is going to be variable every single time the automations run, is being put inside the user prompt. And so the system prompt is extremely important and the user prompt is always variable. Now I have another video on prompt engineering, so I'm not going to go through exactly what makes a good prompt. That's not the goal of today. So if you guys aren't very familiar with prompt engineering yet, please go and watch that video because prompt engineering is perhaps the most important skill anyone can learn in 2025. So as you can see, I just executed this specific prompt with the system message saying you have to respond in a sad tone. I still asked, hi, how are you? But this time it said, I'm doing okay. Thanks for asking. It's been a bit of a rough day, to be honest. How about you? So as you can see, it's responding in a sad tone. So no matter what I put inside the user message, it's always going to also respond in a sad tone because that's saying fixed. Now the next one is an assistant prompt or an assistant message. Now the assistant prompt or assistant message is slightly less important and I don't really use it that often. But the whole idea of an assistant message or the assistant section of a prompt is that you should grab whatever a previous LLM said and put it inside there. So I'll give you an example. Let's say if we have two LLMs and the goal is to create blog posts. One LLM, LLM number one, might be responsible for creating a plan for the post. Then LLM number two will be responsible for writing the post. Now the idea is that the output of LLM number one should be sent over to LLM number two to use in order to create the output of LLM number two. Now the idea is that the output of LLM number one should go inside the assistant message. It's kind of like keeping the chat history so the AI knows what was previously discussed with AI. So if you ever have something like an LLM chain, which is just basically a bunch of LLMs chained together, sending each other messages, then in that case, you can put it inside the assistant prompt and it's meant to make the output slightly better. But as I said, it's not super important and it's not something I usually do. Now the next option you have, which is this toggle bar, says, do you want to simplify the output? So currently with the output that we have, this is a simplified output. It only has however many parameters you see here. Now, if I were to toggle this off and just send the same thing through, as you can see now, the response from OpenAI has a whole bunch of other parameters, like how many tokens was inside the prompt, how many tokens was inside the output, how many tokens was in total with the input and the output, and some other random info that you generally wouldn't actually be using inside your automations. So if you ever have a use case where you want to know the number of input and output tokens, feel free to keep this on. But generally, it's not very much valuable for most use cases unless you're just building out the flow and you just want to turn it on momentarily just to understand exactly how many tokens is being spent inside this API call. And the reason why the number of tokens is relevant is that the number of tokens is what determines the actual cost of using that LLM within that specific API call. So the number of tokens is divided into input tokens and output tokens. So the input tokens are the tokens you have inside your prompt. And if you guys don't know what a token is, so it's pretty hard to explain, but just usually think of it this way. One token is usually about, let's say, 3/4 of a word. So if you have 1,000 tokens, it's basically about 750 words. And so the number of tokens you put inside your prompt is directly related to how much each of your API calls is actually costing. Now, the second component of this is the actual output tokens, which is the response you get back from the LLM. So the longer the response the LLM gives you, the more it's going to cost you, and the shorter it is, the less it's going to cost you. And one thing you also have to know is that when you have thinking models, like the reasoning models I was talking about, like O3 and O4 mini and whatever it's going to be at the time that you're watching this video, the actual thinking process as well, although it's not very much valuable for you, is still going to cost you in output tokens. And so that's why reasoning models are generally more expensive, because they have a higher token count per API call. So the next option that you have is to output the content as JSON. Now this is actually very valuable, and I'll give you an example. So I've just written a prompt saying recommend 10 names for a community that teaches AI automation, like AI Automation Accelerator. Now, if I don't turn on output content as JSON, what's going to happen is that the large language model is going to give me an output like this, saying, sure, here are 10 name suggestions for a community focused on teaching AI automation. And it's basically just normal text in one singular string within the field content in the response of the API call we made to OpenAI. So it's just one long string. But sometimes inside your automation, what you want to do is you want to be able to get that output as JSON so you can grab each of those data points as variables and use it inside the rest of your flow. I can just add provide the output in JSON, And then I can toggle on this output content as JSON. And if I send this through again, as you can see, what happens is now the content field is actually an object with an array inside it called community names. And each of the actual names that it recommends is given to me as a separate string within that array. And so this actually gives me more granular access to each of those data points, so I can use each of these within the rest of my flow. And this is actually very valuable when it comes to building out automations that require LLMs to make certain decisions inside them. And just one thing I want you guys to note as well, you have to make sure that you say provide the output in JSON inside the prompt to make sure that your flow doesn't break. So just toggling on output content as JSON sometimes isn't enough. So I always provide the output in JSON there just to make sure that it doesn't break once I turn on the automation and leave it in continuity. So now moving on, there's a bunch of other options that you have as well that we'll quickly go through. So the first two is frequency penalty and presence penalty. And they're somewhat related. So the idea of frequency penalty is that it assigns a penalty when a certain word is used multiple times. So the more frequently that word is used, the higher the penalty. And so generally you'd use this to make sure that the output is not repetitive. So you want to make sure it's not using the same words all the time and it's not sounding monotonous. The second one is presence penalty. Now presence penalty gives it a penalty if it sees that word present at all. So even if that word exists once, it's going to give it a high penalty. And so generally with presence penalty, it doesn't just make sure that it's not repetitive, but it also makes sure that the output is going to be very dynamic. And it's very useful for creative tasks or brainstorming because it tells the AI to never mention the same concept twice. So the AI will make sure that it's really thinking out of the box if you have the high presence penalty. And when it comes to frequency and presence penalty, the maximum value you can go to is 2. So 2 is the highest value for the penalty for each of these. And so if I make both of them 2, it's going to be very, very dynamic in the output that it gives me. It's going to make sure that the words aren't really that repetitive at all. So I'll quickly show you guys a little trick. If you didn't turn on the output content as JSON and you didn't want to have to look at it like an ugly string that has no specific formatting, you can just quickly search up one of the words you see here. In the search bar, you can say, for example, assistant, because I can see assistant. And then what happens is it actually turns it into a nicely formatted text. So that's just a little hack that I learned that really helped be able to visualize the data a lot easier. And so you guys can do that as well if you're not working with JSON as the output, because you're not going to be every single time. So now as you guys can see inside this specific output, the words that are used are quite dynamic. I can only see automate once. And automate AI is actually a pretty weird word. So as you can see, all of these words are different. And the AI's made sure that it doesn't repeat the same thing twice, and it definitely doesn't repeat it multiple times. So even if I were to remove the frequency penalty, it should still be pretty dynamic because it doesn't want to repeat that word multiple times because of the presence penalty. So as you can see, we still have a pretty dynamic output, but now we can see a little bit more use of automation. I can see automation once, twice, 3 times, 4 times, 5 times, which is a fair few times more. And so the idea is that anytime you want to make sure that your output is non-repetitive and it's creative, you can play around with the frequency and presence penalty. Now the next two is output randomness. One of them is controlling it via temperature, and the other one is controlling it via top P. Now these two are still pretty similar in my opinion to the other two that we discussed in terms of presence and frequency penalty, but these two more so just define in general how random the output actually is. And generally they both kind of do the same thing, but they do it in different ways. And so it's never recommended for you to play around with both the temperature and the top P. You should either play around with the temperature or the top P. Otherwise you're going to get a very weird answer that probably isn't even English. Now to show you the effect of these, I'm going to actually go in the backend or the playground of OpenAI and run the prompts there. So I'm just going to paste in the same prompt that we had before. And now I'm going to put the temperature at the absolute maximum. So the maximum in general is 2, and 2 means be extremely random in the output that you actually give me. So if I send this through, as you guys can see, at some point it stops being English. So it looks like that's Arabic, and then some of those languages I don't even know what they are, and the output just keeps continuing and it's blabbing on. Although all I asked is recommend 10 names for a community that teaches AI automation, it's just giving me a bunch of random stuff. So the output itself is completely random. Now I've brought back the temperature to 1, and now I want to show you what top P does. So top P basically just means choose a pool of the top X% of likely words and then randomly choose from those words. So obviously the higher the percentage of words that you're looking at, then the more likely the output is going to be random. Because if you're looking at the 100% likely words, which means you're looking at every single word and you're going to choose randomly, it's going to be a very random output. But if you're only looking at the top, let's say 1% of words that it could be and choosing from that specific pool, then it's going to be a very deterministic output. And so keeping the top P at 1 should give you a very random output. So with top P, the lower it is, the more deterministic it is, because the smaller number of possible next words it's looking at, and the larger it is, the more random it is, because it's looking at a larger pool of words to choose its next word. Now, the whole idea of presence penalty, output randomness in terms of temperature top P, and frequency penalty is just to be able to control how the AI responds to you and how deterministic or random it actually is. And using them is actually quite complex, and it's very much experiment based. So what I'd recommend is when you want to build a prompt for a client, you can literally just play around with these, increase them, decrease them, and run it multiple times and see which one is giving you the best outputs, and then just keeping those specific settings as you progress with that automation. But generally, for most projects you build, you wouldn't even need to change any of these. They're usually more useful for copywriting or creative tasks. Now, with that being said, the next one is actually pretty important, and that's the maximum number of tokens. So what this determines is how many output tokens you actually get from OpenAI at max. So if I put this on 16 and I run this, what's going to happen is OpenAI is going to respond to me. But as you guys can see, the output is very short. It's only 16 tokens long. It says, certainly, here are 10 name ideas for community focused on teaching AI automation. And as you guys can see, the completion tokens, which determines how many tokens you got back, is only 16 tokens long. So it's very short. So what you can technically do is you can increase this to 1,000 tokens if you only want the output to be maximum 1,000 tokens. And now, as you guys can see, the output we get is complete. And the last one is maximum tool calls iterations. And that one is actually more for AI agents. So we're not going to be talking about it today. Now, this node, as I said, is the most important node of all. If you know how to write a good user message, system message, and you know which model to choose for which task, and you can play around with these sometimes, then you're already 99.9% of the way there. But there is a bunch of other things that you can do within the OpenAI node or within other nodes, and I'm going to go through all of them in just a moment. So just before we go on to image and audio, I want to quickly talk about what assistant is. Now, an OpenAI assistant is basically like an OpenAI custom GPT. That's how I think of it. So you know how on ChatGPT you can build your own custom GPT, and you can call on that custom GPT with putting an @ sign and then putting the name of that custom GPT? Well, building out an assistant is somewhat similar. So if you go back to the back end of OpenAI and you go over to assistants, what you can do is you can build out a custom GPT directly within OpenAI, and then you can actually use that custom GPT via API from n8n. So to do that, what you do is first you'd give the assistant a name. Maybe you'd call it blog writer, and then you'd give it some instructions. And these instructions, as you can see, it's called system instructions. The reason why it's called system instructions is because over here you're putting the system message or the system part of the prompt that we were talking about just before. Because as I said, the system message is going to be the same every single time the AI is being run, and it's kind of just telling the AI how it's meant to act and who it actually is. And so once you're calling on this assistant with a new task via the API, you're giving it a user message, but the system message is just sitting directly within the assistant, and it doesn't change every single time you use it via API. And then what you can do is you can choose the model you want the assistant to actually use, which is similar to what we saw in the previous node with messaging the model. And then you can give it access to certain tools and functions. And this is more or so turning it from a custom GPT more to an AI agent. And so we're not going to be talking about that again today. But generally with assistants, I don't find them super useful, and I almost never use them. I've built a couple before in the past just to experiment with them, but generally I find that just building what you want directly inside n8n gives you much better results, and it gives you more flexibility over time. So when it comes to an assistant, what you can do is you can create an assistant directly from n8n. It basically just has all the options that I showed you inside the OpenAI platform, like choosing the model, naming the assistant, giving it a description, giving it some system instructions, giving it access to tools, and even giving it access to a knowledge base. And if you guys don't know what a knowledge base is, I'm referring to a database that you give the AI access to. So if the AI doesn't know the answer to a question, it can search through that database and it can answer you using the info from that database. And this is generally referring to a concept called RAG, although OpenAI doesn't actually call the knowledge retrieval RAG, they just call it retrieval, but I believe it's RAG. And I've actually got a video on YouTube on exactly what RAG is. So then the other things you can do with assistants from n8n is you can delete an assistant if you built one before and you don't like it anymore. You can list all the other assistants that you currently have, so it'll give you a list of all your current assistants. You can message an assistant, which as I said, is just you sending that user message or that specific task to use that assistant from your automation. You can update an assistant, meaning you can just change certain things about that assistant that already exists inside OpenAI's platform, or you can make a custom API call. And a custom API call is, I don't know why they've put it here, basically just requires you to go and set up a HTTP request node and actually send a custom API call with a URL and all the other things that we've gone through before. So that was assistants. Now, the thing that I want to quickly mention here is, as I talked about before, when it comes to generative AI at the moment, we have 4 main modalities that are super relevant. And these modalities are basically just, let's say, data types. So you have text, you have image, you have audio, and then you have video. And the whole idea of this generative AI boom and what everyone's going crazy about is you being able to go from one of these modalities to another one of these modalities. So for example, when you use ChatGPT, you're sending ChatGPT text and you're getting text back. So that is going from text to text. So what I'm saying is inside the prompt, you're giving ChatGPT some text, and the output you get back from ChatGPT over here is also some text. So that's text to text. Now, the whole idea of generative AI is either going from any of these modalities to themselves or going from any of these modalities to the other ones. And predominantly, it's actually going from text to all the other ones. So for example, text to image is just the image generation models that you've been seeing boom in the past couple of months, where you actually write in a prompt and then OpenAI or ChatGPT or whatever you're using for image gen is going to give you an image as an output. And then audio is also the same thing. So you guys have seen text to speech models where you basically write down a bunch of text, you choose the audio or the voice you want to use, and it actually speaks that text as an output. So that's going from text to audio. You can also go from text to video, which is the one that's being going crazy recently with Google Veo 3. And maybe by the time you guys are watching this video, Google Veo 3 is old news, but at the point of me recording this, it's actually taken the internet by storm and it's pretty crazy in my opinion. And that's text to video because you're writing a prompt and you're getting a full video back as an output. And so as long as you understand that there is these main 4 modalities and the whole point of AI is just to either go from any of these modalities to themselves or any of these modalities to the other ones, you can understand that generative AI is really not all that complex to understand as a whole. Well, of course, if you're not the researchers in OpenAI trying to build better and better models. But for people like us that want to be able to use these models for business use cases, it's really not that hard to understand and be able to use practically. So the reason why I mention this is that with this OpenAI node, you can do 3 things. Number 1, you can write a prompt and go from text to text. Number 2, you can write a prompt and go from text to image. And number 3, you can write a prompt and go from text to audio. So the input is always going to be a prompt or the text, and the output you're getting is either going to be text back, which is the one that I just showed you where you talk to ChatGPT, or it's going to be an image back where you write a prompt and you get an image back, or it's going to be audio. Now, OpenAI doesn't give you access to video over here, and their video model is called Sora currently, and I believe that they've kept it separate from the OpenAI platform as a whole. And so the next thing we'll look at is the image section of the OpenAI node. So inside the image section of the OpenAI node, you have access to 2 operations. The first one is to analyze the image, and the second one is to generate an image. So first, let's actually start with generating an image. Right now, at the point of me recording this video, you have access to 3 models, DALL-E 2, DALL-E 3, and OpenAI's new GPT Image 1. So I'm just gonna go with GPT Image 1, and I'm gonna say, create a realistic image of a man running happily with his dog. So then you can see inside the options, I can also choose the quality as high, medium, low, and I can also choose the resolution as any of these 3 options. So let's just say, let's go with medium quality, and 1024 by 1024 resolution. Let's send this through. And as you can see, the output that we get gives us a binary file. And this file is of type PNG, meaning it's an image. So if I were to click on view, as you can see, this is the image that OpenAI created. Pretty cool, actually. Pretty realistic. I mean, the guy looks pretty realistic. The dog looks pretty realistic and they're running and they're happy. So kind of ticks all the boxes. So not too bad. Now that was us generating an image. So if you guys are building any workflow where you want to generate an image, whether it's for content creation, blog post creation, or any other specific workflow that wants to create an image, you can do it easily just by going into the OpenAI node, going to images, and choosing generate an image as the operation. So what I'm actually going to do is I'm going to show you the other functionality by opening up another OpenAI node and going to analyze image. So now with analyze image, basically as the name suggests, the idea is that you will input an image and OpenAI will analyze that image to understand exactly what's going on inside that image. So for a lot of automations also, this is actually very valuable because if you have some sort of picture and you want OpenAI to be able to understand what's going on inside that picture and maybe write a text description, you would use this specific node. So for example, for our SEO blog post creation at the moment, what we're doing is that we have, let's say a client give us 1,000 images and we need a way to know which one of these images we should put inside which specific blog post. And to do that, what we need to do is we need to write a description about each image. And so as a human, going and watching each of these images and writing a manual description each time is obviously not very much worth it. So what we do is that we use the analyze image node to go through each image, create a description. And so now we store the images along with their description. So then the next time we want to write a blog post, we can just give the AI access to all of the descriptions and say, hey, based off these descriptions, choose which image you want to put inside the blog post. Now, with that being said, you got to first choose the model that wants to analyze the image. So generally it has to be one of the models that is multimodal, meaning they take image as an input and they'll give you text as an output. So let's just use GPT-4o and then we'll keep the prompt as what's in this image. That's fine. And then it's saying, okay, well, what is the type of input? In this case, we know that it's a binary file. So we'll change the input type to binary file. But if the image was stored on the cloud somewhere and you had a URL to access that image, you will give the URL here. But in this case, as I said, it's a binary file. And then it's saying, okay, well, what's the name of that binary file? As you guys can see in the previous node, the name of that binary file or the field name for that binary file is data. So we'll keep it as it is. That's completely fine. And then it's saying, well, do you want to simplify the output or not? And as you guys saw before, simplifying the output basically just make sure you only get the data points that you actually care about from OpenAI and not all the other random stuff. So we'll keep it as simplify the output. And then you can say, okay, well, what level of detail do you want to go into? Do you want it to be low detail, high detail, or auto detail? I'll just leave it as auto detail because the higher the detail, obviously, the more it's going to cost. And then it's saying what length of description do you want? So the output that the AI gives me, what's the maximum number of tokens in that specific output? So we'll just delete this and we don't really care about it. Let's run this and see if it realizes that it's a guy running with his dog. So just going to quickly show you guys the image on the left again so we can refresh our memory. There we go. This beautiful guy running with his dog. I know that sounded pretty sus, but I didn't mean it that way. It says the image shows a person in an orange shirt running alongside a golden retriever on a leash. They are outdoors on a path surrounded by greenery and trees. Both of them seem to be enjoying the moment. Perfect. That's like the perfect description of exactly what's going on inside this image. And so OpenAI, kudos to you. You did a very good job. So that's the idea. You can either generate images or you can analyze those images to turn it into text. So you can say, for example, what color is this dude's shirt? And it will know, okay, well, this guy's shirt is, I guess that's orange. Or what color is the dog's hair? Well, it's yellow. How many trees are in the background? 3, I can see. So it's pretty amazing the things you can do in different scenarios. For example, we had a client once approach us that wanted us to be able to find cars for them online. And we plan to use this analyze image model to grab a bunch of images of cars from different directories and then run it through the model to say, okay, well, is this car matching the description of exactly what we want? For example, does it have 2 stripes running down the middle? Or is the rims black? Or is the rims red? Or something like that. So it's actually very valuable when it comes to building out automations for certain niches. And by the way, just to remind you guys, I will give you guys access to all of these as examples. So you don't necessarily need to sit down and try and build any of these from scratch. Just download it from the description and then play around with it to understand exactly what's going on. So everything is going to be given to you inside the description of this video. Now, the next set of actions on OpenAI is to do things with audio. So the first one is to generate audio. The second one is to transcribe a recording. And the third one is to translate a recording. And so if you think about the modalities that I was just talking about, generate audio means let's go from text to sound or voice or speech or whatever you want to call it. Transcribe a recording means let's go from sound to text. So it's the opposite way around. And then translate a recording is an interesting one. It basically just says grab this voice recording and convert it to English. And that conversion is actually going to happen to text. So it's still this way. And I'll take you through an example of each of them. So first, let's generate audio. When it comes to generating audio, you have access to two models currently. And both of these models are TTS models, meaning text to speech. Exactly what I was talking about just then with the modalities. So out of the two models, TTS1 and TTS-HD, or TTS1-HD, TTS1 is the standard one, and TTS1-HD is the one that's really crisp and really good. So in scenarios where you're happy to wait a little bit longer to get the perfect output, like if you're building a voiceover for a video or something like that, then you can go with TTS1-HD. It's going to have better quality, but it's going to take longer to get that output, and it's also going to cost you more. But in scenarios where speed and reducing latency is the goal, like if you're building some sort of voice agent or something like that, then you want to go ahead with the TTS1 model because it's quicker and it's going to cost you less as well. But if you want to compare the two of these, TTS1-HD is going to be a little bit better, a little bit more crisp. So let's just go with TTS1 for the sake of this example. Now, if you want to see what each of these voices sound like, you can go back to the OpenAI platform, go to real time, and then on the right hand side, you have access to each of these voices. So Alloy, Ash, Ballad, blah, blah, blah. And if you click on that start button, it will tell you exactly what the voice actually sounds like. And then what you can do is you define exactly what text you want to convert to voice. So I can just say, for example, the biggest change in history is right around the corner. AI is changing the way we do business forever. So what's going to happen is if I run this, it's going to convert that to a voice. You can also control exactly what type of file you want to get as an output. Let's just say MP3. You can control what the speed of the audio of that voice is. We don't really care about that. And you can also control what the field name of that output is going to be, which is also not very relevant from 99% of use cases. And so let's just run this and see what we get as an output. So as you can see, we got back an MP3 file. And if I click on download, I can show you guys what it says.
The biggest change in history is right around the corner. AI is changing the way we do business.
So there you go. It basically converted this text to audio and it let me download it as an MP3 file. So technically now what you can do is you can grab that recording and you can transcribe it, meaning go from speech back to text, or you can grab any recording and you can translate it from whatever language it is to plain English text. So I'll just quickly show you the former. You want to quickly just go and transcribe a recording. You want to make sure that it's looking at that specific file. So I'm saying the input data field name is data, which is perfect. That's correct. And if I execute this, it's just going to convert it back to text, and that was a mistake because I had the wrong credentials. There you go. It's going to say the biggest change in history is right in the corner. AI is changing the way we do business forever. Now we're done with the OpenAI node, which as I said was the most important one of all. The next one we'll quickly take a look at is the basics LLM chain node. Now when it comes to the basic LLM chain, as you guys can see, it also gives you access to a prompt user message box, which basically just means where you put the prompt so it sends it off to the AI. Very similar to what we saw with OpenAI node. But then it has this toggle that says require specific output format, which is probably the most important thing about a basic LLM chain node. And what this require specific output format basically does is that it just tells the AI that, hey, you have to give me this specific format inside your output. And so if you're using this LLM inside a chain with a bunch of other LLMs, where you want one part of the output of this LLM to go into this LLM, and then one part of the output of this LLM to go into this LLM, and you want to make sure that the actual output format is deterministic so the flow doesn't break over time, you would use a basic LLM chain. Similar to what we saw with the OpenAI node and being able to output the content as JSON. But this actually just gives us a bit more flexibility to choose exactly what we want inside that specific output. So to do this, what you have to do is you have to set up an output parser. When it comes to an output parser, there's two that you have to primarily worry about. First one, and the most important one, is a structured output parser. And the structured output parser basically just tells the AI exactly what the output should include and what it should look like as a JSON object. So you can do that in one of two ways. The first one is you just give the AI an example of what a good JSON output object would be. For example, in this case, it's saying that you want to have two parameters or two fields in the output. One of them is a string for the state, and then one of them is an array for the cities. So I think this is talking about an example where you have a state and it's saying the cities that sit within that state. So it's basically you giving the AI an example of what a correct output would look like. But the one that I like to use more often is where you actually write down the full scope of exactly what you want, along with the description of what each parameter is about directly inside the output parser. So the standard template that it gives you looks like this, but I don't really like this that much. I'm giving you guys access to this template here. within this node. So if you guys ever want to just find my template, go back here. Basically what this template is doing is it's saying, okay, in the output that you give me, you have to give me two fields. It sits within the properties object. The first field is called field name number 1. The type of it is a string. The description of it is this. So for example, if you want the AI to give you the name of cities, the first field name would be cities. So that's the name of the field of the output. The type of it would be string because you're expecting the output to be a string. And then the description of it would be, these are the cities inside this specific state, if that makes sense. And then you just put a comma, and then you put the second object within that properties object. And the second object would just be about the second parameter or the second field you want inside the output. So for example, in that case, it was talking about the state. You would change the field name to state. You would say the type of the output is also going to be a string. So it's going to be state, and state is a string. And then the description of what that specific field actually means. So the state of question or whatever you're going to say. And then at the very end, you're also saying that these are the fields that are required and have to be in every single output. So we're saying that field name number 1 and field name number 2 always have to be in every single output, no matter what the task at hand is. And that way the AI knows that it always have to put these two fields inside whatever JSON object it gives me as an output. So this is super valuable. So I've got a good example that I'm going to show you that you'll understand exactly what a structured output parser actually does. So as you can see, I've defined some random data here, and the data is just saying Lisbon, Portugal is a picture, skew, I don't even know how to say that word, city of sunshine, trams and soulful fado music. Its charm lies in the mix of historic neighborhoods and easy access to beautiful beaches, but while the weather is great, the city's steep hills can be tough to navigate, especially on foot. So it's basically just said, hey, we're talking about the city Lisbon. These are some good things about it, and these are some bad things about it. Whoops, there we go. And it's put that inside a JSON string called data. So now what we're going to do is we're going to pass that over to a basic LLM chain. And inside the prompt, we're going to say, give me the list of all cities mentioned below with its pros and cons as mentioned below. So I'll just quickly show you guys what this would look like without the output parser. So if I were to turn this off and then execute this step, as you can see, the output is basically saying, here's a summary of the pros and cons of Lisbon. Quickly do the hack that I told you guys before. There we go. So it's actually giving it to me as a string in natural language. But let's say in a case where I actually want the pros and cons or whatever in a nice JSON formatting, what I'll do is I'll just toggle this back on and I'll connect the output parser. And then inside the output parser, what I've done is I've said, these are the parameters that I want. So the first parameter is city, it's of type string, and it's the name of the city. The second parameter is pro, it's of type string, and it's the good thing about that specific city. And actually, I just realized I didn't give it the cons, so I'll quickly just do that too. So I'll actually say this is the pros, so multiple good things about the city. And let's make it an array. And then let's just add a new one called cons. We'll make it an array, and we'll say the bad things about the city. And then we'll just fix up the JSON so it makes sense. And we want to say we want the city, the pros, and the cons as required fields. So what we just did is we said, these are the three fields that we want for you to give us: city, pros, and cons. And this is what the description of each of them is. And this is a type of data we expect to be inside the value of that field. So let's try and run this and see what happens. As you guys can see now, what we have in the output is a very nice JSON formatted output with exactly the parameters that we define. The first one is city. Second one is pros as an array, and the third one is cons as an array. And the reason why this is super valuable is that now we have access to this granular information, and we can use these data points later on inside different parts of the automation depending on our use case. So using a basic LLM chain is really, really valuable if you guys want to be able to get a specific output format so you can use it fractionally in different parts of your automation. Because sometimes you don't want to send over the entire output of the LLM within another node. Sometimes you just want to take the pros. Sometimes you just want to take the cons. Sometimes you just want to take the name of the city. And so if you want that granular access, you do have to use a basic LLM chain. Well, you don't have to. You can still achieve it with an OpenAI node, but it's going to be a bit more stochastic, variable, or just not good. So as I said, you can also achieve the same objective by just using a JSON example or an example of what the desired output should look like. So in this case, I just said there's three fields: city, pros, cons, like we saw before. First field, it just has one single string called city. Second field is the pros, it's an array, and the third field is cons, and it's also an array. Now, considering these fields are very descriptive and the task is very simple, the AI is likely not going to get this wrong. But if the fields get very complex and you kind of have to explain exactly what's going on, then it's better to actually use pure JSON to write down exactly what each field means and what output format each of them should be. In this instance, just because it's super easy, the AI should still get the right answer. So if I send this through, as you can see, we got the right answer. We got the first string, city, then we got an array pros, and then we got an array cons. So now just to show you what the last output parser actually does, the item list output parser, I'm going to change the data that we're feeding the basic LLM chain. Instead of just giving it info on Lisbon, what I've now done is I've given it info on multiple cities. So the first one is Lisbon in Portugal. The second one is Tokyo, Japan. You can barely see, but we got Argentina here, and then we got Canada here. So we did 4 different cities in 4 different countries. And we put all of it inside one single string called data. And now inside the basic LLM chain, I'm saying, give me the list of all the cities mentioned with their pros and cons. And then the idea is by having this item list output parser, basically what I'm telling the LLM is that I want you to give me the output as multiple items, depending on how many items you think or you see fit. So I can actually be specific with how many items I want, but if I just put -1, it tells the LLM to just choose however many items you think you require. And if you want to define a specific separator that should separate the items, like every time you go to a new line, put that in a new item, you can define it here. But for the case of us, it doesn't really make sense. So if I run this, technically what it should do is it should give me 1 for each of the cities. There we go. So as you can see, we now get 1 for Lisbon, Portugal. We get 1 output for Tokyo, Japan. We get 1 for Argentina, and we get 1 for Vancouver in Canada. So because we didn't actually define the specific JSON formatting with the city and pros and cons, it didn't give it to me in a nice format, but it was able to give me 4 items, 1 for each item inside that specific string, which was each city we defined inside that string. And so the reason why this is valuable is because now we have 4 items, and we can separate these items based off an if statement or whatever it's going to be, and then get it to run through different branches separately to each other. Now, the next node we want to quickly talk about is the information extractor node. So the information extractor node, as the name very much suggests, is just a node that allows you to extract specific pieces of information from the input prompt or text that you send over to the LLM. So if you want to send the LLM, let's say, a very long document or a very long string, and you want the LLM to find one little piece of information and then give that little piece of information to you, you can use an information extractor node to say, hey, can you please locate this, and this specific piece of information from this very long piece of text, and then output it to me. So just going based off the example we had before, let's run that again. This is the string with the multiple cities. What we can do is we can just pull in the multiple cities here. There we go. And then we can define what specific information we're looking for inside that specific string. So to do that, you have 3 options. You can either choose from attribute descriptions, or generate from JSON example, or define below. So defining below is basically just what we did with the output parser, same sort of deal. JSON examples, also what we did with the examples, I've already shown you that. So it's basically just the output parser, but now you get it inside this nice interface. And then the from attribute descriptions is the one that I would recommend you guys use, because it makes everything really easy and you don't have to sit down and write JSON code. So to do that, all you do is you click on add, and then it's basically the same thing as we saw inside the output parser with the JSON example. You define the name of the field you're looking for, the type of data it is it a number, is it a string, is it a date, is it a boolean, and then you define the description of that specific field. So let's just say, according to our use case, first one is city, it's a string, and it is the name of city mentioned. And then we can define if it's required or not. So same exact deal, but now we have it in a nice interface. Then we can say, for example, pros. So you can't actually define for it to be an array, so we'll just keep it as a string. And then let's say the pros of the city, keep that as required, and we won't even worry about cons. So let's just execute this and see what happens. Now, as you can see, it says a model subnode must be connected. So this is more similar to how AI agents work. You actually have to connect the OpenAI node separately to it, or the brain separately to it. Click on plus, and then choose whichever chat model you want to use. So you're not just stuck with OpenAI. You can use Anthropic, or you can use Google or DeepSeek, or whatever you want to use. But I generally just use OpenAI because it makes life easy. And then you want to just choose the credential you created before, and then choose the model you want to go with. So GPT-4o mini should be enough for the task that we have in hand. We just execute the step now. And what it'll do is it'll use the LLM to actually perform this information extraction task. Now, right now we're inside the logs, and I said this is more agentic stuff, but as you can see in the output, what it gave us is just the first city. It just gave me Lisbon. It didn't give me anything about Tokyo, Japan, and the other ones. And the reason for that is this specific node isn't really meant for extracting multiple different items of each specific field. So as I said, because it doesn't allow you to choose an array as a data type, it wouldn't be able to get like 4 different cities and 4 different pros for each of those cities. I hope that makes sense. So if you want to get something where it's like multiple cities, just use the basic LLM chain and use the item output parser so you can create multiple items. But for this one, it's more so suitable if you just have one really long piece of text and you want to extract different fields from that piece of text, but not multiple versions of those different fields. So I hope that makes sense for you. But it does pretty well if you want to give it, as I said, a lot of text and just get 1 or 2 or 3 bits of info that you want to use across the rest of the automation. And it's also in a JSON format, so you can still use these variables separately within the rest of the flow. There's also 2 options you can add. So first one is a system prompt template. Now, as I said, all of these different fancy things like information extractor and so on and so forth, they're still just using an LLM. They're basically just using the OpenAI node that I showed you before. But they're actually defining a system prompt that gets it to act in a certain way. So for this one, it's saying you're an expert extraction algorithm, only extracts relevant information from the text. If you don't know the value of an attribute asked to extract, you may omit the attribute's value. So that's being sent off to the LLM, and then this info is being sent off to the LLM, exactly what fields you want inside one nice prompt, and then the LLM is giving you a response like this in JSON formatting. So all of these fancier nodes, they're just n8n's way to abstract or make simple doing specific tasks using these LLMs. But technically, they're all just still using this LLM. And then the last one is batch processing. Now, batch processing is also pretty important. The whole idea of a batch is basically just to like batch it up. Let's say if you want to send 50 items, you would batch these 50 items, let's say to batches of 5. That means you have 5 items, 5 items, 5 items, 5 items, and each of these are inside one container, right? And you have 10 of these, that's 50. And then the idea of a batch is that you would only do 5 at a time. So to define that, what you do is you say the batch size has to be 5 or whatever you want to choose it to be. And then you define a delay between the batches. And that's really why it's relevant. So you can define delays between batches. So with API calls, there's generally something called a rate limit. And a rate limit basically just means how many times can you call that API within a specific time interval before the API goes, stop man, you've called me too many times. And especially LLMs, they all have rate limits. So you can't send 100 or 150 calls to an LLM within a minute. It's just going to stop at some point and say, hey, wait 30 seconds and try again. And so if you have a big flow with, let's say, hundreds or just 100 items running through it, what you want to do is you want to turn it into batches of 5 or 6 or 2 or 3 and run those batches and then wait in between. So if you wait, let's say 30 seconds between each batch of 5, you will run through the entire 100 items, but because it's waiting 30 seconds in between each 5 of them, it's not actually giving you a rate limit error. And so to summarize that, only use batch processing if you have a lot of items going through the flow, and you just want to make sure that the API doesn't give you a rate limit saying, hey, you've asked too many times in too short of a time period. And then the next AI node that we have is what we call a question and answer chain. And the whole idea of a question and answer chain AI node is to get the large language model to ask a bunch of documents or a database a question so it can answer your question. So just to put that in perspective for you, if you, for example, have a bunch of policy documents and you want to build a support agent or a customer support agent, and you want the support agent to use these policy documents to answer customer queries, what you would do is you would give this LLM or this support agent access to these documents, and then when a customer asks a specific question, like for example, what's your refund policy, the AI or the AI agent will go and search through these documents, find the info about refund policies, grab that info, and then use that info in order to answer your question. So it's kind of a way of you being able to give AI access to a bunch of documents that it can use without you having to put all of these documents directly inside the prompt. And it's a technique that we call retrieval augmented generation. And I know we just spoke about this a little bit earlier on. So with the question and answer chain, it defaults to being used as a chatbot, which says if it's connected to a chat trigger node, because it's very similar to an agent, but we don't necessarily want it to be a chatbot. So we'll just say define below. And then what you basically do is you define whatever question you have, or you'd pull it in from the previous node. That's obviously not English. And then you will change the system prompt if you'd like, but you have a pretty standard system prompt that tells it, hey, you should answer the questions based off the info you get from the docs. And then we have the batch processing option that I just went through as well. And the idea is you'd connect it to an OpenAI brain or any other brain like an agent, and then you give it access to some sort of documentation or some sort of documents or some sort of database that the AI can use in order to answer questions. And so if I wanted to go through these, it would be very similar to me explaining how AI agents work. And so I'm not going to go through this right now, but I'll go through it inside the AI agent module. So we'll leave that for now. So the next AI node that we have is a sentiment analysis node. So to understand what a sentiment analysis node does, you first have to understand what sentiment actually means. And this is a pretty core fundamental thing when it comes to AI. It's a pretty important topic. And the whole idea of sentiment is just to understand the emotion behind words. So for example, some words might be positive words, some words might be negative words, and some words might just be neutral words. Or in other cases, some words might be happy words, some words might be sad words, and some words might be, again, I guess, neutral words. So the idea is to not just look at words as a bunch of characters that connect to each other, but actually understand what the feeling or emotion behind that word actually is. And so when it comes to sales, there's a really good example of sentiment in terms of giving someone a pitch about your product. So if you wanted to sell a really old car, and I'm going to try and draw a car. Let's say if you wanted to sell a really old car, you can refer to a really old car in two ways. Number one, it's a really old car. Or number two, it's a really vintage car. Now, if a salesman told you it's a very vintage car, vintage is a positive word. You're like, whoa, that sounds expensive. That sounds cool. But a really old car sounds like it's a really crappy car, right? So that's a negative sentiment word. So although you're technically saying the same thing, you're saying it's an old car, and you're saying it's a vintage car, with both of them this means it's pretty old. When you call it vintage, you have a positive sentiment or positive emotion associated with that specific word or that specific sentence. And then when you're saying it's an old car, it's actually a negative sentiment associated with that specific sentence or that word. And so the idea when it comes to sales and what they teach you is that you should always try and have positive sentiment when you're trying to show your products. So even if you're going to talk about the part of your product that's not amazing, you'd still want to put it inside positive words, because psychologically that makes the buyer feel something positive, not something negative. And so the idea about sentiment analysis is just getting AI to grab text and tell you what the sentiment of that is. Is it a positive sentiment? Is it negative sentiment? Or is it neutral sentiment? Or you can even define whatever name you want to have for positive, negative, and neutral, like happy, sad, or angry, or whatever it's going to be. So I've quickly defined an example. In this one, I've just created a field called text to sentiment analysis. And if I run this, you can see it's a string and it just has some text. It says the morning started off with grey skies and a series of small annoying problems, spilled coffee, a dead phone battery, and an email full of bad news. Well, obviously already sounds like negative sentiment. Nothing catastrophic, but enough to put a sour taste in the day, yada, yada, yada. So the idea is I have some text that is obviously got some negative sentiment associated to it. So it's got a negative feeling. It's using words like grey skies and problems and dead phone and that sort of stuff, which are all negative words. So if I were to pass this through a sentiment analysis node by just dragging and dropping this in, I would get the sentiment analysis node to choose what the sentiment for this text actually is. So I can also define what categories the sentiment would be. As I said, positive, neutral, negative is a normal one, but if you want to make it happy, sad, or whatever you want to make it, you can as well. I can define the system prompt that's being sent over to the LLM to decide what the sentiment should be. We just leave it as default. I can say to include detailed results, and I'll show you what that means in just a second. And then I can define auto fixing to just say, hey, if the output was not proper, please try and run the LLM again to make sure the output is exactly how we expect it to be. And then batch processing we also went through before as well. But just to quickly run this and see what sentiment analysis actually does, as you can see, it's giving me an error because I forgot to connect it to a model. So we'll connect it to OpenAI so it has an LLM to communicate with, and then we'll just change that to OpenAI credential. There we go. Let's run that and see what happens. So as you can see in the output, it will take the items that come in through one of three branches. If the item was of positive sentiment, it will go off the top branch. If the item was of neutral sentiment, it will go off the middle branch. And if it was of negative sentiment, it will go from the bottom branch. So as you can see, the bottom branch is the one that became green. So it identified that the text we sent over was of negative sentiment. And if we go in here, you can also see that it's the case because it says negative branch, one item. And neutral and positive don't have anything. Now, if I wanted to say include detailed results and send that through, what you'd see inside the negative branch is more granular information as to exactly what the result of that sentiment analysis was. Like how strong the actual sentiment was towards the category it defined. So 0.8 is actually pretty strong. And then how confident the AI is of the answer it actually gave. So the AI is 90% sure that the answer it gave is correct with an 80% strength that it's negative sentiment. And so obviously the stronger it is and the more confident it is, the more likely the answer or the sentiment analysis is going to be correct. And so the idea of this is like if you have any sort of use cases where it's sales related or customer service related, like for example, you want to make sure that your customer service team isn't using negative sentiment, you can transcribe all the recordings, send it through the sentiment analysis, and then get the AI to decide if something has negative sentiment, and then get it to alert you via email saying, hey, this staff has just talked to a customer and they had negative sentiment. And then if it happens multiple times, you would obviously have a chat to them and you'd basically just teach them how to be more positive in the way they communicate with customers. And so that was the sentiment analysis node. The next one is what we call a summarization chain. Now, the summarization chain is another node which, especially now, you wouldn't really use that much, but I'll tell you what it does. So the whole idea of a summarization chain, as the name suggests, is to be able to summarize some input text. So let's say, for example, if you wanted to send a document that was 20 pages long to an LLM and get the LLM to summarize that document for you. Now, LLMs generally have what we call a maximum context window, or just a context window. And what that maximum or that context window actually defines is every one time you get the AI to do something via an API call, let's say, how many tokens is being used, both in the inputs and in the outputs. And the context window basically says for this specific LLM, let's say GPT-4o, it can only be, I don't know, let's say 1,000 tokens at max, both in the inputs and outputs. And so the idea is if you wanted to send over 20 pages to an LLM that had a small context window, it would be hard for you to send these 20 pages all at once, right? Because it will exceed the number of tokens that you're allowed to use within that specific use of that LLM. And so this summarization chain basically just chunks this text into multiple pieces and then summarizes each of these chunks and then goes and combines it together to give an output to you. So instead of you having to send over, 20 pages in one go, you send over 2 pages at a time, and then you combine all of that together in one summary and it gives it out to you as an output. And so the idea, as I said, is to define a chunk, and then you also can define a chunk overlap. And the idea of chunk overlap is, let's say, for example, if we have one document and we want to define a chunk where it's divided into 2 sections, right? Sometimes because you're defining the chunk based off number of characters, you might chunk it at the middle of a sentence. So there's like a sentence going on here and then you've just chunked it from the middle. So the idea is that by defining an overlap, you can say, okay, well, let's take this one until here, and then let's take this one until here. So effectively what happens is the first chunk would be this much and the second chunk would be this much. So as you can see, this section in the middle is an overlap, and yellow is probably not very visual, but this section in the middle is an overlap that's included in both chunks, because chunk 1 was all the way until here and chunk 2 was all the way until here. And by including this overlap, we're just trying to make sure that we don't cut off ideas or concepts or sentences midway. So you'd usually define an overlap that's obviously smaller than the actual chunk size itself. So generally 1,200 is pretty good. But to give you guys an example of the summarization chain, I've just defined a new field called random. And what random has, it basically is just a string with a bunch of random information about AGI, or artificial general intelligence, and it's pretty long. And then inside the summarization chain, you can basically say which data you want to summarize. So is the data actually coming from a document? In that case, you'd have to connect it to some sort of document. Is the data coming from a binary input, which means like some sort of file that's coming from directly within the workflow? Or is it coming from the previous node in JSON, which what we have is obviously in JSON. So we just keep it as that. And then the chunking strategy could either be advanced or simple. Advanced would basically use a recursive text splitter, which basically is just a way for you to split text into chunks recursively, but it's not super relevant, so I'm not going to be talking about it. And I'll talk about it inside the AI agent module because it's more relevant for AI agents and especially for building out RAG agents or agents that have access to databases. But let's put this back on simple and let's just say 1,000 and 200. Let's actually change that to like 400 and 150 because we don't really have that much text as input. And then you can define the summarization method and prompts, which not very relevant, or the batch processing, which also I talked about before. So if I run this again, as you can see, it will give me an output, and the output is just a summarized version of what that text actually has. And it just did that recursively by summarizing in different chunks. Not a node that I would say is very relevant in today's day and age because context windows, or the maximum number of tokens an AI can process at once, is actually increasing exponentially. Right now, we're sitting at 1 million context window with some of Google Gemini's products and also the GPT 4.1. And 1 million context window is like what? Basically, as I said, 750,000 words. Just imagine how many books 750,000 words is. It's a lot of books. So you can literally put that many books inside one specific input-output pair of an LLM. So you wouldn't really have a scenario where you'd probably need to summarize recursively. Well, unless you do, then in that case, please let me know what that scenario is. So the next AI node we're talking about is the text classifier node. And the text classifier node is actually one that's quite important as well. And it actually touches on a very fundamental functionality that AI actually has, and that's building a classification system. So classification basically just means put the output in one specific class. So whatever the input to it is, it's just saying, okay, well, that's either class A, class B, class C, or class D. And your job as the LLM or the AI is to decide what class this output should be in. Should it be in class A? Should it be in class B? Should it be in class C? Or should it be in class D? So the idea with a text classifier node is basically the exact same thing. You pass it a bunch of text, you give it the categories of what the output could be, A, B, C, D, and you give it a description as to what each of those categories actually mean and when it should be inside those categories. And then you run it and it should classify the input data within one of those categories that you defined. So one example of this, which you guys may have already seen if you follow some of my work, is a scenario where you have a bunch of emails come in and those emails should be classified as either sales emails that the sales department has to work on, or CSR, or basically customer service emails that the customer service department has to work on. And the way you do this is you build some sort of text classifier, and you get the text classifier to read the email and decide, okay, is this sales or is this CSR or customer service? And then you'd have some sort of automation or logic defined to handle the sales emails and another one to handle the customer service email. But with that being said, as you can see over here, we have 2 items. So 2 emails. One of them is saying, I'm interested in your AI automation services, particularly around marketing and lead gen. Could you share pricing, setup time, yada, yada, yada. And the second one says our AI cold calling agent stopped responding during calls today. We tried restarting, but it didn't help. Please check workflow, yada, yada, yada. This is urgent. So as you guys can clearly tell, the first one is a sales email and the second one is one that should be handled by customer service. And so inside the text classifier node, what we've done is we've dragged in that data so it reads through that text so you can classify it for each of those items. And then we've defined the 2 categories. So the first one is category sales. And what it means is emails that are sales related. And the second one is category CSR or customer service representative. And what it means is emails that are customer service related. So you can also define multiple options like allow multiple classes to be true. So in a case where that email could be both sales and CSR, or some other option that kind of overlaps both of these, do you want it to also go into that field as well, or that branch as well? For this case, we'll keep it off. Then the next option is saying, okay, well, if it doesn't fit within any of these, what should we do? Well, in that case, we're saying just discard the item, but you can also decide to add it to an extra output called the other branch. So you don't actually lose that data. It just sends it to an extra branch called other that you guys can see down here that you can then handle using certain logic. So we'll just put it on discard item and then the system prompt will leave as it is because n8n's worked pretty hard to make sure they get the good system prompt. And some of them they actually just get from the LLM Chain documentation. So smart people have worked on this. But with that being said, the idea is that once we've connected a brain, the text classifier will get each of these items and then send it through to one of these branches. Then you can build a workflow or some logic to automate something for each of these emails. So if I just run this now, As you guys can see, it says one of them went to the sales branch. The one that went to the sales branch says, I'm interested in your AI automation services, particularly around marketing and lead gen. Perfect, that's correct. And one of them went to CSR that says, our AI cold calling agent stopped responding during calls today. We tried restarting, but it didn't help. So perfect. So it literally realized one of them was sales, one of them was CSR, and it sent them to different branches. And the idea, as I said, is now I'll build logic for the sales branch and I'll build logic for the CSR branch. And that way I can automate my entire inbox. So check out the inbox management automation that I've shared with you guys. So if we go back to the AI nodes, as you can see, there's one called AI Transform. AI Transform basically I've talked about inside the data handling part of this module. And the idea about AI Transform is that it will allow you to write plain text and get JS or JavaScript code as an output. And that's more so for data transformation. Let's say if you have data coming in and it looks a certain way, and you want to be able to define some logic to change that data or transform it to another format, like you want to filter it or you want to summarize it, or you want to add the number 3 to each of them or whatever you want to do, you can use the AI transform node. Actually, I'll show you guys. Define instructions in natural language, like do XYZ, and then it will write the actual JavaScript code for that to happen. And then just by doing that, the data that will come in will transform. So as I said, I've talked about this before, and I don't really want to touch on it again. Then the evaluation node is one that you would use during testing, and it's related to this evaluations tab. It's actually pretty new in n8n, well, new for us. I don't know when you guys are going to be watching this video. And the idea of it is that once you've actually built out your automation, you will run a bunch of A/B tests to see if it's actually giving the outputs that you want. And then you can tweak things like the prompt and that sort of stuff to see if making the prompt different actually brings you a better output. And so realistically, it's used for debugging and testing after you've built out the automation. And I just realized you guys couldn't actually see it, but now you can see it. It's this one here, the evaluation node. And then we've got some other AI nodes, but these ones are all for AI agents. They're basically just tools that you can connect to AI agents that I'll talk about inside the AI Agent Masterclass. And so that was literally all of the AI nodes that you had to know in order to build extremely powerful automations. If you just know these and know how to use them and understand when you should use each of them, you will literally be able to build automations that will keep everyone amazed and surprised. And so I hope you guys found this video valuable. I'll see you guys in the next one.